Chocolate, a universal delight. But have you ever wondered what makes a perfectly crafted bar so irresistibly smooth and shiny? It's not just about the ingredients or the recipe. The secret lies in a fascinating scientific process called tempering. Tempering is the art and science of controlling chocolate's crystal structure, transforming it from a simple liquid into a stable, delicious solid. Without proper tempering, chocolate can be dull, crumbly, and prone to an unappetizing white bloom. But with it, perfection awaits. Today, we'll delve into the molecular physics behind this culinary magic, exploring how cocoa butter crystals dictate chocolate's final form. The journey begins with cocoa butter, the fat component of chocolate. It's unique because it can crystallize in several different forms. These are known as polymorphs, and there are 6 main types, labeled Form 1 through Form B. Each has a distinct melting point and structure. When chocolate is melted, all these crystal forms are destroyed. The goal of tempering is to encourage the formation of just one specific type. That ideal form is Form B. It's the most stable and gives chocolate its desired characteristics. A firm snap, a smooth melt, and a beautiful sheen. The process involves carefully heating and cooling the chocolate to specific temperatures. This thermal manipulation guides the cocoa butter molecules. First, chocolate is heated to melt all existing crystals. Then, it's cooled to allow the less stable crystal forms to begin to appear. Crucially, it's then reheated slightly. This melts away the undesirable crystals, leaving behind only the stable Form B seeds. These Form B seeds act as templates, encouraging all subsequent crystals to form in a desired structure as the chocolate cools and sets. This precise temperature control is paramount. Even a few degrees off can lead to a completely different and often disappointing outcome. The molecular alignment within Form B crystals is what gives tempered chocolate its characteristic strength and ability to snap cleanly. Observe the flawless surface and brilliant shine of these perfectly tempered bonbons. This is the visual hallmark of successful tempering. Now, let's see what happens when tempering goes wrong. This is chocolate bloom, a common sign of failed tempering. Bloom occurs when unstable cocoa butter crystals melt and recrystallize on the surface, often due to temperature fluctuations. It's still edible, but the texture is grainy, and the visual appeal is significantly diminished. The molecular structure is simply not aligned. Understanding the molecular physics of tempering empowers us to create chocolate that is not only delicious, but also visually stunning. From the chaotic dance of molecules to the precise formation of Form B crystals, every step is a testament to scientific precision. So, the next time you enjoy a piece of perfectly tempered chocolate, remember the intricate molecular journey it undertook. It's where chemistry creates perfection, transforming simple ingredients into an extraordinary culinary experience.